Good morning, everyone. My name is Jay Torres. I'm a sales engineer based in Southern California. And in this video, I'm going to do an intro to VRF. First of all, what is VRF? VRF stands for Variable Refrigerant Flow, and it is a scalable zoning technology. VRF can provide higher levels of comfort, control, and efficiency. And we do this using variable speed compressors in our outdoor units and EC motors in our indoor fan coils. VRF is also an adaptable technology. We can use this in any type of application, ranging from healthcare to education, K through 12, universities, office, high-rise residential, you name it, any type of application would be a good application for VRF. When we're talking about VRF, there are two main system types, heat pump and heat recovery. In a heat pump system, fan coils are capable of providing either heating or cooling based on the outdoor unit mode. When we're talking about heat recovery, fan coils are capable of doing simultaneous heating and cooling, both at the same time. And within heat recovery, there are two separate types of technologies. There's two-pipe and a three-pipe system. In a two-pipe system, you have two refrigerant lines, and in a three-pipe system, you have three refrigerant lines. You have your liquid, suction, and your mixed phase refrigerant line. Let's look at the primary components of a heat pump system. You have your outdoor unit, your indoor units, and your control system. The outdoor unit is what controls the compressor logic. It maintains the operational mode, so it'll tell the indoor fan coils whether you're in a heating or in a cooling mode. Your indoor units transfer hot air or cold air into the space, and this is what allows for optimal zoning. You can apply a fan coil unit to each individual zone for greater levels of comfort and control. And your controls monitor the space temperature and controls the indoor fan coil. We have different types of remote controllers, and we also have remote and central controllers. Here's a general piping diagram for a heat pump system. You have your outdoor unit, you have your two pipes going from the outdoor unit to the inside space, and you have your Y branches that split off, that goes to each individual fan coil, and each fan coil is connected to its own remote controller. So what are good applications for a heat pump? Basically anything that has a large open space or a single common area. So churches, lobbies, bullpen areas in an office building with a large common area with cubicles. These are all good candidates for a heat pump system, since they will most likely be in either one mode or the other, either heating or cooling. Let's look at the primary components for a two-pipe heat recovery system. It's very similar to a heat pump system where you have your outdoor units, you have your indoor fan coils, and you have your controls. But we also introduced another piece of hardware called the multi-port distribution controller. And this is what controls the state of the refrigerant going from the outdoor unit to the indoor unit. And this is what allows for simultaneous heating and cooling. Let's look at a three-pipe system. Let's look at the primary components of a three-pipe heat recovery system. Same thing, you've got your outdoor units, you got your indoor fan coils, and you got your remote controllers. In a three-pipe system, we call them the flow selector boxes, and this is what controls the state of the refrigerant going from the outdoor unit to the indoor unit. And this is also what allows for simultaneous heating and cooling. And here's an overview of the different piping schematics for our different systems. You have your simple two-pipe heat recovery. We have our three-pipe heat recovery with one-to-one flow selector boxes. We have our three-pipe with heat recovery with multi-port distribution boxes. And we have our simple two-pipe heat pump system. And here you can see the different color coding of the different refrigerant pipes. You have your mixed phase, you have your hot gas, you have your suction, and you have your liquid line. And as you can see with the different types of technology, the amount of refrigerant piping needed depends on the type of system. So if you look at a two-pipe heat recovery system, you can see that there's a lot of refrigerant piping as you have to go from each fan coil back to the central multi-port distribution controller. If you look at the three-pipe heat recovery with the one-to-one boxes, it's less piping, but you have a lot more labor since you're installing each fan coil with its own single-port box. If you look at the three-pipe heat recovery with multi-port boxes, it's a little bit of best of both worlds. You have refrigerant piping going from each multi-port box to each fan coil, And you can strategically mount these in different areas of the building so you don't have to home run back and forth between the fan coil and its flow selector box. So where would you use heat recovery? Basically any building that has multiple zones that typically wouldn't be used or would have different load profiles. So office buildings would be a good example, assisted living, schools, universities, dormitories, mid to high-rise, multifamily. These would be good applications of using heat recovery, as you can serve all of the different spaces, but they don't all have to be either on or off at the same time, and they don't have to be in the same mode of operation at the same time, either heating or cooling. So this is what allows heat recovery systems to be very energy efficient. We also get asked, where would we use 2-pipe and where would we use 3-pipe? They're both heat recovery. They both do the same thing, but where would you use one versus the other? And I would say we would typically use a 2-pipe heat recovery system in a large, wide, open building, typically like 1 to 2 floors, where you can mount the multi-port distribution controller in a central location, since these are usually larger, anywhere from 8 up to 12 ports. So we would mount those in a central location, and then it would be easier to route the refrigerant piping from each zone back to the multi-port distribution controller. So some examples of this would be shell and core TI type buildings, where you would have a office building with different zones, different suites that would be leased out by a tenant, and they don't all have to be occupied at the same time. So as the owner leases out those offices, the tenant can come in and install a fan coil and then hook up to the VRF system and then be served by the central system. So where would you use 3-pipe heat recovery? Typically mid to high-rise buildings would be great candidates for 3-pipe heat recovery systems. Hotels, office buildings, multifamily, these are good candidates for 3-pipe heat recovery system, to where you can mount the outdoor units up on the roof, and then you can pipe down and have a multi-port flow selector box on each floor, branch out, serve the different zones, and then continue down on to the rest of the building, multi-port box, branch out to different zones, etc., etc. And it's important to know which system would be the best candidate for which type of heat recovery system, either 2-pipe or 3-pipe. So you can see in the slide below, depending on the type of system and the layout of the building, you can see that one system is more beneficial than the other system. In this example, using a 2-pipe system and having the big multi-port distribution controller on one end of the building is not the best use of that system, because you have multiple refrigerant lines basically home running to the same area. So there's a lot of redundant refrigerant piping, to where if you used a 3-pipe heat recovery system with multi-port boxes, you can strategically install those flow selector boxes where they need to go and reduce the number of piping and install labor to install those. Now, the advantage of a 2-pipe heat recovery system over a 3-pipe heat recovery system is that there's less labor to install these, typically less labor to install these systems. With a 2-pipe heat recovery system, you inherently have less piping and less brazing to do than on a 3-pipe heat recovery system. You can see that there's less connections to braze on a 2-pipe heat recovery system versus a 3-pipe heat recovery system. Less connection points means less labor, which means the contractor can get in and out of the job faster, and there's less labor to charge the owner with a 2-pipe system versus a 3-pipe system. I hope you enjoyed this video to Intro to VRF. If you have any questions, please leave them in the comment section down below. I'll also leave links to my email address, and you can reach out to me directly with any questions or comments that you might have. Thanks for watching, and I hope you enjoyed this video.